Hello, welcome all the dear students in today's video of subjects Maths 1. I am Sri A. N. Gonugade, Assistant Teacher, Sri Nageshwar High School, Rashid Durg. The name of the first chapter is Linear Equation in Two Variables. Already we learned about how to write determinant and how to solve the determinant, how to find out the value of determinant. Now we are going to find out the solution of simultaneous equation by using determinant method. Also it is called as Cramer Rule because this method is developed by Gabriel Cramer and hence it is called as Cramer's rule. So how to solve the simultaneous equation using this method? So these are the steps. So first of all, we take the general simultaneous equation a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Here a1 and a2 are the coefficient of x and b1 and b2 are the coefficient of y. c1 and c2 are the constant terms. X and y are the variables. So to solve this equation we want to write three determinant d, dx and dy, and there is certain method to write these determinants. So determinant d we write like this: in first column the coefficient of x, in second column the coefficient of y, b1 and b2. So in this way we write the determinant d, and by solving we get the value of d. How to write dx, second determinant? The coefficient of x, a1 and a2 are replaced by the constant term c1 and c2, and coefficient of y, p1, p2 as it is. And by solving we get the value of dx. Then determinant dy. So dy, in first column coefficient of x as it is, and coefficient of y replaced by the constant term c1 and c2. So in this way we write the determinant d, dx and dy, and solving all the determinants we get the values of d, dx and dy. And then by the Cramer's rule, x is equal to dx by d and y is equal to dy by d. These are the formulae to find out the value of x and y, and final answer xy is the solution. Then in this way we solve the example. Now example 1. Solve following simultaneous equations by using Cramer's rule. Particularly they are mentioned by using the Cramer's rule. So this is first example: 3x minus 4y is equal to 10 and 4x plus 3y is equal to 5. These equations are denoted by equation number 1 and 2. Then the first determinant d. Look here, 3 and 4, the coefficient of x right here in first column, minus 4 and 3 are the coefficient of y in second column. And we know how to solve this by taking cross multiplication. So 3 and 3 minus 4 and into 4. So 3 and 3, 9, minus 4 into 4, minus 16. So this minus sign and minus 16. So minus plus. So plus 16. So 9 plus 16 we get the answer 25. So value of d is equal to 25. Then dx. Look here, when we write dx, the coefficient of x replaced by the constant term 10 and 5. So 10 and 5 in first column. In second column the coefficient of y minus 4, 3 as it is. So in this way we write the determinant dx. And by solving this, cross multiplication, 10 into 3 minus 4 into 5. So 10 into 3, 30, minus 4 into 5, minus 20. So minus plus 20. So 30 plus 20 is equal to 50. Then dy. The coefficient of x 3 and 4 as it is. The coefficient of y minus 4, 3 replaced by constant term 10, 5. Again by solving the determinant 3 into 5 minus 10 into 4. So 15 minus 40, answer is minus 25. So value of dy is equal to minus 25. So we get the value of d as 25, the value of dx as 50, and value of dy as minus 25. Then by Cramer's rule, x is equal to dx by d. The value of dx is 50, value of d is 25. So 50 upon 25 is the 2. So value of x is 2. Then y is equal to dy by d. So dy is minus 25, d is 25. So minus 25 is 25 is equal to minus 1. So 2 and minus 1 is the solution of this equation. Then the second example. 2m plus 3n is equal to 12. M minus n is equal to 1. So this simultaneous equation in variables m and n. So here we want to find out the value of m and n. Let's denote the equation number 1 and equation number. This is equation number 1 and this is equation number 2. Now we find out the value of d. The coefficient of m in first column 2 and 1. There is one coefficient. Then coefficient of n 3 and minus 1. And then by solve. Look here. 2 into minus 1 minus 3 into 1. So 2 into minus 1 minus 2 minus 3 into 1 3. So minus 2 minus 3 minus 5. So minus 5 is the value of d. Then dm. The coefficient of m replaced by constant term. So 12 and 1 in first column. Coefficient of n 3 and minus 1 as it is. Then cross multiplication 12 into minus 1 minus 3 into 1. So minus 12 minus 3, it is minus 50. Then dn, coefficient of m 2, 1 as it is, coefficient of n replaced by 12 and 1 constant term, and then again cross multiplication 2 into 1 minus 12 into 1. So 2 into 1 2 minus 12 into 1 12. So 2 minus 12, it is minus 10. So here we get the value of d is minus 5, value of dm minus 15, value of dn minus 10. Then by Cramer's rule, m is equal to dm by d, n is equal to dn by d. And then putting value of dm, dn and d, we get the answer as m is equal to 3 and n is equal to 2 by solving this. And 3, 2 is the solution of this simultaneous equation. In this way, we learn here how to solve the simultaneous equation by using determinant method or Cramer's rule, and it is very important example. So steps to solve this examples are: we want to write d, we want to dx, dy, and solving the determinant we get the values of d, dx and dy, and by using Cramer's rule x is equal to dx by d, y is equal to dy by d. By using this formula we get the final answer. Okay, so in this way we complete this video. Thank you very much.